Okay, so we have been looking at reasoning under uncertainty, and we have seen so far two approaches to that. One is the closed world assumption, in which we just simply add the negation of every atomic formula which is not entailed by the knowledge base. So, then we saw something which was a little bit finer in its approach, which was circumscription, which basically said that there are a certain set of predicates which you can minimize and the rest you leave alone in some sense. And then you basically minimize those predicates that you have selected, which in some sense represent abnormality essentially. So, of whatever you are trying to achieve essentially. Now, today we look at a third approach, and this is called default logic. And this is due to a person called Raymond Leiter, who did a lot of work in logic related thing, and in fact he is more well known for his theory of consistency based diagnosis essentially, which I think we might have mentioned somewhere along the way. Now, what a default logic does is that it is in some sense the opposite of closed world assumption essentially. You add certain statements which you assume to be true essentially. So, it is the opposite of closed world assumption, in the sense that in closed world assumption we added the negation of every atomic predicate. Here we add some positive statements. So, some things which can can consistently be believed in essentially. So, the simplest example of course, is that if you say that Tweety is a bird, then you can add an assumption that Tweety can fly essentially. Now, what default logic does is it gives you a mechanism to decide when to make such assumptions and in what context such assumptions can be made essentially. So, a default logic is broken up into two parts. One is we can write this as F, which is a first order theory. It basically means a set of sentences in first order logic, and the other is you can write like this, which is a set of default rules. So, a default rule is made up of a triple, which is says that alpha, beta, delta, or we can also write this as alpha, beta, then delta. Here alpha is a prerequisite, beta is called the justification, and delta is called the conclusion. And the basic idea is that if alpha is given, which means alpha belongs to the knowledge base, and it is consistent to believe beta, then conclude delta essentially. So, this phrase that it is consistent to believe beta is basically one of the kind of statements that we keep making when we talk about default reasoning. If it is consistent to believe something, then you can go ahead and assume that that thing holds essentially. And how do we say that it is consistent to believe in beta is that if you cannot show not beta essentially. That is a typical way of doing things, and this is what we are looking at in default logic and also in auto epistemic logic, which we will do next essentially. So, there is a special kind of a default rule which are sometimes called as normal rules, because they in some sense try to capture normal behavior, and normal rules are of the kind alpha, beta, beta. It says that if it is consistent to believe beta, then go ahead and assume beta is true essentially. So, beta, or maybe I should write delta, because we are talking about delta as the conclusion essentially. So, a normal rule says that if it is consistent to believe in delta, assume that delta is true. So, the conclusion is also the same as assumption, or you can say belief, something that you are willing to believe in. So, an example of a normal rule is bird Tweety flies Tweety, then flies Tweety. So, essentially a normal rule associates a certain property with a certain class, and it says that it is normal to assume that property unless you can show otherwise essentially. So, if it is a bird, then it is normal to assume that the bird can fly unless you can show that not flies, that particular bird is true essentially. We will also write normal rules as alpha with double arrow delta, or here bird Tweety Okay, so, what does default logic give us? It gives us a mechanism whereby we can state a set of rules which are called default rules, which are not part of the knowledge base essentially, but these are kind of a separate part of the knowledge base, you might say. It is partitioned into a first order part and the default rules part, and essentially the default rules tell you what assumptions or what conclusions you can reasonably draw essentially. Under what context you can draw certain conclusions delta essentially. So, associated with default logic, we have this notion of default extension, which asks what are the set of beliefs one can hold. So, given a knowledge base and given a set of default rules, what is it consistent to believe in essentially. So, that is called an extension. It is very similar to the notion of extension that we talked about when we were discussing inheritance. We had said that what can we believe about a particular individual, and then we had said that we can define a notion of an extension which is a maximal sub hierarchy which is unambiguous essentially, and which is reachable from that individual. So, in the similar notion we have a notion of an extension which says that given something what all can we believe in. So, we can define this that given a default theory which is given by this first order theory and default rules. A set of sentences epsilon is an extension of the theory if and only if for every sentence phi the following holds, that phi belongs to this extension if and only if the default theory union a set of assumptions that we can make, which are given by a set of sentences called delta, such that there must be a rule alpha which allows you to make that assumption, and that rule must belong to your default rules. Then alpha must belong to the extension. Notice we are saying that alpha must belong to the extension. We are not saying alpha must come from the first order theory. So, the fact that we are allowing alpha to belong to the extension means that if you make some certain assumption and you add a certain fact, let us call f 1 to the extension, then you can treat that f 1 as a prerequisite for another assumption essentially. So, you can have a chain of assumptions essentially, that is possible, and not beta does not belong to the extension. And these two sets together they entail the statement pi. So, pi so the extension is made up of all those sentences which are entailed by, we can write this as f union delta, where delta is a set of reasonable assumptions. So, this delta of course will correspond to this set. So, we can see now that if we have an example in which the first order theory has, so I will just use the short forms, that Vt is a bird, chili is a bird, not flies chili. So, this is what we dealt with earlier itself in circumscription, but then we had a circumscription rule. Here we have a default rule which contains a normal rule which says that if yeah, you can assume them to be different here. No, you can, it does not matter whether different or same in this case, I think. X so, if we take this example, then you can see that what are the assumptions we can make essentially. Remember that this rule is equivalent to saying bird x flies x implies flies x. Okay, so, what do we need? That for each bird, there are two birds in this case, negation of flies x should not be in epsilon. So, we can only construct those extensions where the negation of flies not flies x is in the is a we are allowed to add for flies x, because that is what the normal rule says, that if you say that x is a bird, then you can add that flies x to the set of assumptions, because you can add that delta to the set of extensions. Remember that the extension is made up of all sentences which are entailed by the first order theory and the set of assumptions, which means the set of assumptions are also entailed by the first order theories, by the default theory essentially. So, obviously, we cannot add, for Chile, but can add for Tweety essentially. Why can we add this for Tweety? Because we cannot add it for Chile, because we know that not flies Chile is already in the first order theory, which means it is already in the extension, and the condition says that the justification must not be negated in the extension essentially, and the justification is that Chile can fly, and that is negated by the extension, because it is there in the first order theory itself essentially. So, we cannot add the assumption that flies Chile to the set of assumptions, but there is nothing which stops us from adding flies Tweety to the set of assumptions, because the extension, which is the first order theory plus any assumptions that we can make, does not entail not flies Chile essentially. So, we will never be able to show not flies Chile. So, we can add flies Chile to the extension essentially. So, the difference between this and the closed while assumption is that here we have added an assumption, and the assumption that we have added is delta is equal to flies Tweety, and once we add this assumption, this is entailed by the extension. So, it is a part of the extension essentially, which means that we can believe that Tweety flies essentially, but we are not allowed to believe that Tweety does not fly essentially. But we can have situations where there are multiple extensions. So, let us look at an example where the first order theory is let me write this completely now. Bird, let me use Peppy and penguin Peppy, and the default theory says that. So, I will just use Peppy here. So, whenever we are talking about default rules, we can essentially have to create one rule for every individual that we want to apply it to essentially. So, when you have a rule of the kind bird x, then you can add flies x, then you have to do that for each individual. So, we have two rules. One rule says that birds can fly, which we have applied to Peppy and said that if Peppy is a bird, then we can add the assumption that Peppy can fly. It is a normal thing for a bird to fly. It is also a normal thing for penguins not to fly essentially.
We have not applied it for all the birds, but just for one instance.
Whatever we want to talk about. In this case, there is only one bird in the knowledge base, so we are talking about that. You can see that this has two extensions. In epsilon 1, uh, flies Pepi, and you can work this out, not flies. Because once you add one assumption, you can add the assumption either flies Pepi or you can add not flies Pepi. If you add the assumption flies Pepi to the knowledge base, then you can conclude of course that Pepi can fly, but you can no longer add the assumption not flies Pepi because of the rule by which the extension is created. Remember that alpha colon beta implies delta, means if you want to add delta, or if it is a normal rule, then if you have alpha implies delta, if you want to add delta, negation of delta must not be entailed by the knowledge base, and if you add one of them, the other one will be not possible essentially. Now, this is of course something that we have been encountering all along, that you can have ambiguous knowledge bases in which you can have different sets of beliefs which are allowed by the knowledge base essentially. And then we have been trying to say that okay, some of them are more normal than the other, and in the inheritance hierarchy kind of a system that we discussed earlier, we could see that certain beliefs overrode certain other beliefs essentially, and in some sense the more specific belief overrode the more general belief essentially. So, if we knew something that Tweety is a bird and Tweety is a penguin, penguin is something which is more specific, and so we would believe whatever we believe about penguins essentially. But in default logic, that is not possible essentially, that is not so easy to handle. One could try something like this. One could say that if you wanted to be more precise, we could say something like this, that for all x penguin x implies let us say water bird x, we could add to the first order knowledge base or first order theory, and we could modify our rule as follows, that bird x, and if it is consistent that flies x and not if we modified our knowledge base to say that penguins are water birds, and we modify the rule for bird which says that it is normal for a bird to fly as long as it is not a water bird essentially. If it is a water bird, then it cannot fly essentially. So, the moment when we say that Tweety is a penguin or Pepi is a penguin, the first order rule will create an entailment that Pepi is a water bird, which will stop the flying rule for being applied essentially. We could even try something like this, bird x flies x and not penguin x. This will enforce that if you know something to be a penguin, then that thing will not be able to fly in your belief system essentially. But it is not an entirely satisfactory solution, because this basically means that you are adding exceptions essentially. You are saying if x is a bird and x is not a penguin, then x can fly. Then you will have to say if x is a bird and x is not an ostrich, then x can fly essentially, and that kind of a thing. It does not try to capture the kind of normal behavior that we want to associate with birds essentially. And this is a sort of problem we keep facing in default reasoning essentially. Let us look at some more problems with default logic. Let us consider default logic in which the first order theory is empty and there is only one rule, and this rule says that if now again I will ask you to work this out for yourself. You can see that this theory has no extensions. That you cannot create an extension in which anything you can believe in essentially. Because if you try to create an extension in which you add not p, then you can only do that if it is consistent to believe in p, and it is consistent to believe in p only if not p is not in the extension essentially. So, you are trying to add an extension not p, not sentence not p to an extension only if it is not in the extension. So, obviously, you cannot create an extension, and such a default theory would not have any extensions. So, this is not too much of a problem, but consider another default theory in which you believe the first order theory is empty again, but the default rule says that if it is consistent to believe in p, you can add p to the knowledge base essentially. So, what should be the extensions for this? So, again if you go through the details, you will see that this has two extensions. One contains all tautologies. Remember that tautologies are true in any extension essentially, by definition essentially, that if you have an extension, then all tautologies would be included in that essentially. The other one has all tautologies plus entailments plus p and its entailments. So, there are actually two extensions to this, one in which p is not present, which is also an extension, and one in which p is present. You are allowed to add p because the extension does not entail not p essentially. Now, this is a very circular kind of a thing which we want to avoid essentially. We are saying that if you can believe in p, then you believe in p essentially, or if it is consistent to believe in p, where p is any sentence. If you can believe in p, then believe in p essentially. Now, in some sense we do not want to simply keep adding things that we want to believe in. It is like that is too fanciful an idea essentially. So, one would prefer this one. Yes. Because how can you believe in an arbitrary p? So, there are ways in which people try to assume to do this. One way is to say that always choose the minimal extensions in some sense essentially, or always if one extension is a subset of another extension, then choose the one which is a subset of the extension, that is a minimal extension, right. There is another definition which was given by Reiter, and he says that if you define the following, that if for any set S, define delta S as follows, that if alpha, beta, delta belongs to the set of rules, alpha belongs to delta S, not beta does not belong to S, you define your delta that we were talking about earlier, or the set of reasonable assumptions as follows, which says that you can add those assumptions to the set delta S, where the negation of beta must not exist in the original set S that you started with essentially. Whereas, alpha can be in delta S, negation of beta must not be in the original delta S essentially. And then we say that for a grounded extension, the extension must be equal to delta S essentially. So, essentially it is a restricted version of the original extension. It allows only certain sets of facts which were not negated in the original original extension to be added essentially. Finally, if you look at this default rule, then what does it say? It says that you can add negation of P, let us say P is an atomic sentence, if it is consistent to believe in negation of P, which means that you cannot derive P. So, you can see that this characterizes the closed wall assumption. So, closed wall assumption can be simply captured by this one default rule. It says that you can add any negative statement provided you cannot prove its contrary essentially. So, you can add any negative statement provided it is consistent to add that negative statement, which means you cannot prove P essentially. Now, there are certain problems with default logic in the sense that it's despite its name, it is not very much like a logic, it is basically a logic augmented with a set of default rules essentially. So, in the next class we will try to look at something similar, which says that if it is consistent to believe in something, then believe in that, but we will try to put that in a logical framework, and that framework is called auto epistemic logic, and we will look at that in the next class. So, I will stop here.